Hi everyone, I'm Rachel English from the Space Foundation Discovery Center. Welcome to Blastoff, our new virtual programming series. I hope that you will join me twice a month to explore all of the ways that space affects our lives here on Earth and do some fun activities along the way. Today, we're going to be talking about the search for life in our solar system. As long as we've been looking up at the stars, we've been looking for signs that we are not alone in the universe. In 1899, while working at his workshop right here in Colorado Springs, Nikola Tesla believed that he had received a static signal from the planet Mars. He's probably actually just hearing interference from a European radio experiment. When NASA launched the Voyager 1 and 2 probes in 1977 on a journey to reach the edge of our solar system and go beyond it, each one carried a sort of time capsule, an introduction to Earth for any other space explorers that might find it. The time capsule is recorded on a 12-inch gold-plated phonographic record, lending it the name the Golden Record, and contains sound and images designed to portray the diversity of life on Earth. All life on Earth is carbon-based, combined primarily with hydrogen, oxygen, and nitrogen. The presence of water, plus an energy source like the light from our sun or chemical energy from a deep-sea vent, allows these elements and many others to combine, react, and create life. Life on Earth is incredibly varied, but we're all made up of the same basic building blocks, from the smallest phytoplankton to the largest blue whale. If we find life on other worlds, will it look like any life we recognize? Will it even be carbon-based? It probably won't look like little green aliens. If we do find life, it will likely be microbial, so small we cannot see it without a microscope. Or it might resemble extremophiles here on Earth. Extremophiles are organisms that can survive in very harsh environments, like hydrothermal vents deep in the ocean. They have evolved to withstand high pressures and temperatures, or extreme conditions. Conditions outside our planet would require any life form to be able to withstand very hot or very cold temperatures, as well as extreme pressure situations like those that we find at the bottom of our oceans. When we look at how life evolved on Earth, we start in our oceans. Likewise, when looking for signs of life elsewhere, we start by looking for water. Saturn's moon, Enceladus, harbors a large ocean under huge sheets of ice 11 to 14 miles thick. Jupiter's moon, Europa, also hosts an ocean. Could there be life there? Mars was once covered in water. Could it have harbored life? To learn more about the search for life on Mars, let's check in with one of our volunteers, Keith.
Hi, my name is Keith. I've been a volunteer here at the Discovery Center now since the summer of 2018. And although my background and career were 37 years working at Chevron, I've always been an astronomer at heart and have really loved working here at the Discovery Center where I get to use that skill and love. So let's talk about what we're looking at here. We're looking at a full-scale model of NASA's Viking lander. Now right now there are two of those sitting on the surface of Mars. And that's pretty cool, huh? So the last Apollo mission landed on the moon in December of 1972. And then pretty soon after that, NASA got busy and landed Viking 1 on Mars in July of 76, and then Viking 2 in September of 76. Now each mission also contained an orbiter, and we'll talk about that in a minute. So Viking 1 was the first spacecraft that the United States successfully landed on another planet. And that's pretty cool to think about. Okay, so at the time of their landing, NASA had put one object in orbit around another planet, and that was the Mariner 9 spacecraft. It went in orbit around Mars in 1971. It operated for about 16 months there, and it was the very first spacecraft anybody had actually put into orbit around another planet. Now, it took the pictures that allowed the Viking mission to proceed. However, the resolution of those pictures was not that great. It was actually 320 feet per pixel. So when we think about it, the smallest thing we could see on the surface of Mars was the size of a football field. So despite this, though, both Viking missions did land successfully. Now, the Viking orbiters took pictures that were 26 feet per pixel, so it was 12 times better than the Mariner 9 photos. And just as an FYI, the current Mars Reconnaissance Orbiter takes pictures of Mars with 1 foot resolution. Now, the main purpose of the Viking missions was to look for signs of life. You have to put yourself way back into the 1970s and realize that we hadn't even seen the surface of Mars until July of 1965, when the Mariner 4 flew by that planet. Until then, we had no idea of what Mars even looked like. And even after the Mariner 9 photos, scientists could not rule out the existence of life. So this is why we went to the surface. Now, the Viking landers also took the first color photos of Mars. Now, the American flag that you see on the lander was more than a patriotic symbol. It was also used to calibrate the color camera so that our Mars photos were in true color when we looked at the surface. Now, the search for life was done using this long sample arm that you see right here. It reached out, it dug into the surface of Mars, and it deposited sediment into 3 separate compartments. You can see the compartments up there. And this was designed to have 3 separate experiments to look for signs of life on Mars. The first experiment was called the Gas Chromatograph, and it had a mass spectrometer. Now, it was looking for signs of life, so it was looking for organic molecules, carbon molecules. It found none, and this was a really big disappointment. The second experiment was called the gas exchange experiment, and it hoped to find signs such as when you put carbon dioxide in with plants and you see they released oxygen. That's what we're looking for, but again, we had no such luck. But here's where things get interesting. There was one last experiment, and it was called the label release, and it put nutrients into these soils. And the results on both Viking 1 and Viking 2 seemed to indicate that some sort of metabolism was going on. And this was really interesting. So what happened here? Well, the designer of this experiment still thinks that the only answer is that there was some sort of life in the surface. But almost all of the scientists disagree. And we believe that the results indicate some sort of unusual chemistry on the surface caused by this soil being exposed to solar radiation for 3 billion years. And we haven't been able to duplicate these results on the surface of Earth, and that's probably why. Now, the Viking missions were an amazing technological success, if not so successful in the search for the actual life in our solar system. But today, NASA continues to look for signs of life on Mars in areas where we now know there was once water. So what's going on right now? NASA is sending the Perseverance rover to Mars in July of 2020. Now, it's going to search an ancient lake bed for signs of life in our continuing 44-year search for life on Mars. Thank you.
Thanks, Keith, for showing us all about the Viking lander. If we do find signs of life in our solar system, past or present, it will likely be too small to see with our naked eye. Instead, we look for bacteria and other microorganisms that were also the first signs of life here on our own planet. Bacteria exist all around us. Some of them are good, and some of them are bad, like the ones that make us sick. The good ones can even help us make food. Yeast is a microscopic single-cell organism that converts its food into alcohol and carbon dioxide. This process is called fermentation, and it's what helps bread rise. I'm going to show you how to make a home for the wild yeast that lives all around your kitchen, called starter. Starter is a mix of flour and water, and it will be the food that our wild yeast feeds on. This is my starter, called Rachel Jr., and it's about 4 years old. Can you see how bubbly it is? That's the carbon dioxide being released by the fermentation process. Happy yeast, happy bread. It smells really good too. Every starter is different because the yeast that lives on your hands and in your kitchen will be different than the yeast that lives on my hands and in my kitchen. There are even starter hotels around the world, so your starter can be exposed to different kinds of yeast. So today I'm going to show you how to make your own starter that you can use to make bread at home. So what I have here are our 2 ingredients, flour and water. And so this is about 100 grams of flour. If you don't cook with a kitchen scale at home, that's fine. It's about a ½ cup. But really the most important thing is that you have an equal amount of each ingredient. So we're going to add the same amount of water as we have flour. And we're just going to pour the water straight into the flour. You can see it's not mixing all the way, so I'm going to have to get a little stir, and I'm just going to start stirring that up. It's going to make kind of a paste. looks like dough, doesn't it? It's like bread dough already. Okay. So we've got our little snack for all of our wild yeast. And now all we would do is set it aside for about 12 hours before we would come back and see if we've got any nice bubbles. And then we would scoop out about half of it and repeat the process. So we discard half, we add more flour, we add more water. And over time, you get something like Rachel Jr. here, my starter, which is going strong for about 4 years. So it's nice and fermented as opposed to this. And you can kind of see that they're very different textures. And Rachel Jr. definitely has a lot more bubbles. And that is how you make sourdough starter. I hope you bake a lot of delicious bread with it. If you do, please share it with us on social media. Thank you for joining us today on Blastoff. I hope you enjoyed the activity, and I can't wait to see you next time. Bye.